Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more all about respiration. Now in other videos we've looked at the word formula for respiration. Glucose plus oxygen turns into carbon dioxide plus water with the release of energy, which of course is the whole point behind doing it. The carbon dioxide and water are just waste products because we took the glucose, which we've got its formula here, and we did that balanced equation. I don't know if you were with me for that video there. We took the glucose, we added some oxygen in, and we kind of smushed all the molecules around, ripped them apart, put them together in other orders, and came out with carbon dioxide and water. And every time you're breaking bonds, you're releasing energy. So we took this one quite large molecules, and we actually made 12 little itty-bitty molecules from it. So that was quite good, a lot of energy released there. And that's great, that's normal respiration, and that's what goes on all the time. You know, you're walking down the road, your leg muscles are needing energy to do that contracting to make you walk, and they do that by all the little mitochondria in your cells merrily chomping away at that glucose, plus the oxygen that you're breathing as you're going along. They're turning it into energy and releasing the carbon dioxide that you breathe out and the water that you also breathe out as water vapour. Incidentally, on this here, when you're breathing in the oxygen from the air, you're taking about, I don't know, about 4% of it, 5% of it there. Oxygen is normally about 21% of the air, and when you breathe out, it's about 16% of the air that you're breathing out. So you're kind of keeping about that 5% of the air there. And you're replacing it by breathing out an equivalent amount of carbon dioxide and water vapour. So the amount of air you breathe in and the amount of air you breathe out are the same. They've just got different chemical compositions. There's more carbon dioxide and water, about 4% carbon dioxide and water vapour, and there's less oxygen when you breathe it out. But imagine you're walking along, doing your aerobic respiration. Oh yes, posh word here, aerobic. A-E-R Aerobic respiration. Aerobic's just a posh word, means with air. So that's using the oxygen. Aerobic respiration. You've probably come across that in exercises. People talk about, we're going to do some aerobics. What they mean is they're doing aerobic exercise. Exercise whereby you're using this equation in your body. Basically what it means is you can keep breathing while you're doing it. And things like, you know, walking is aerobic. Some activities, however, are not aerobic. For example, you're walking along and all of a sudden out from behind a dustbin comes a Dalek. And you start running, as people do when they see Daleks. This is the ones that go kind of can fly, so they can go really fast. So you're running away from this Dalek as fast as you can. And obviously you're going to start breathing faster because your muscles in your legs are going to want to use more energy. So you're going to have to do this respiration equation a lot more. Okay, so they're busy converting all this glucose into energy as fast as you can, taking in loads of oxygen, because on the one where we did it with the chemical formulas, we noticed it took 6 molecules of oxygen for every 1 molecule of glucose to break down. So it takes a lot of oxygen. So there you are, breathing as fast as you can to get all the oxygen into the system. And you've got to run so fast that basically you can't breathe fast enough. You can't get enough oxygen in to convert the glucose into energy. What are you going to do? Well, your body has a very, very useful way of coping with that. Instead of using aerobic respiration that uses oxygen, it says, I haven't got enough oxygen, I need to do some more. So it does anaerobic respiration as well. So obviously it's going to use the oxygen where it can, but when it needs more energy, it will also do anaerobic respiration. Anaerobic does not use air. So we lose the oxygen bit. Different stuff in, different stuff out. So for anaerobic respiration, we're just using the glucose. That's all, no extra oxygen. So, having a look down my handy dandy list of things you can make, starting off with the glucose, which is that, we've got to turn it into something else that doesn't require any extra oxygen. Now the aerobic respiration used extra oxygen, and it gave out water and carbon dioxide. So we needed the extra oxygen to make those. So if you haven't got any extra oxygen, you're not going to be able to make those. There's not enough in there to make those as well. But there is something on that list you can make. It's the lactic acid. You might have spotted. It's exactly half. How convenient. So glucose can turn into lactic acid. It's a chemical that happens to have exactly half of the number of everything. So one glucose can turn into 2 lactic acids. One molecule of glucose turns into 2 lactic acids. We're breaking bonds. Breaking bonds releases energy, so it definitely releases energy, but not as much as aerobic respiration. Aerobic respiration is far more useful. But if you haven't got enough oxygen and you can't do the aerobic, you have to do the anaerobic respiration. Okay, it doesn't release as much energy, but it doesn't require the breathing. Okay, so that's quite handy. And it's useful to get you out of situations where, you know, you're being chased by a Dalek or something like that. But there's a problem. The other one produced carbon dioxide and water as its waste products, and that's easy. There you go, I've just got rid of carbon dioxide and water vapour. How do you get rid of lactic acid? You can't breathe it out. Well, the answer is you don't. You can't get rid of the lactic acid. It won't go round in your bloodstream and come out in your lungs or anything like that. You can't get rid of the lactic acid. And it actually builds up in your muscles, and you will, I'm sure, have felt this. If you do running and you do too much, you get that, oh, that ache. Yes, that is the build-up of lactic acid in your muscles. It actually hurts after a while. So when we do anaerobic respiration, we're turning the glucose into lactic acid, and we do that because it doesn't require any oxygen. It's kind of an emergency store. But the problem is you end up with lactic acid built up in your muscles, and that will start hurting after a while. So what we'll need to do is actually convert that lactic acid into the water vapour and carbon dioxide, because those we can breathe out. So what actually happens is you're walking along, aerobic respiration, all very nice, breathing in oxygen, breathing out the waste products, fine. Dalek appears, you start legging it down the road, your body goes, oh my word, I haven't got enough oxygen. Quick, kick in the anaerobic respiration. So it starts breaking down more glucose, fast as it can, breaks down this glucose, releases the energy, so you manage to get out of the way of the Dalek, jump into a passing TARDIS if that happens to be one, producing lactic acid as the waste product. Your body can't get rid of the lactic acid, so when you've finished running away from the Dalek, you go around the corner, you're still panting. You're not running anymore, but you're still panting. Why is that? Well, it's because of this. It's called an oxygen debt. You've been doing respiration without using as much oxygen as you should. You've got to pay it back now. And that's why after you've finished running, you still need to breathe hard, because what you're doing is converting the lactic acid plus oxygen into water and carbon dioxide. It's what you would normally have done for the aerobic respiration, except you didn't have enough oxygen at the time. So you just kind of converted it into lactic acid so that you could get the energy. And then when you've finished running, you take some more oxygen by this heavy breathing to repay the oxygen debt, because that lactic acid's built up in your muscles. You keep doing the breathing, plenty of oxygen to turn your lactic acid plus oxygen into water and carbon dioxide, which is what you would have done had you been doing aerobic respiration. You then breathe those out, lactic acid disappears, everything restored, nice cup of tea, job done. So that is aerobic and anaerobic respiration. I'll see you next time, Batty fans.
Mwah! Mwah! Mwah!